For the last example here of this type, before we move into some different trig identities, this one we're asked to integrate from pi over 3 to pi over 2 sine squared x over the square root of 1 minus cosine x dx. Now, sometimes there's more than one way to work some of these problems, and sometimes you're going to have to use a combination of identities with these. The way that I'm choosing to work this problem is I'm going to make use of a couple identities. The first one says that sine x is equal to 2 sine of x over 2 cosine x over 2. It's a double angle identity. And then the other one I'm going to make use of is that 1 minus cosine x over 2 is equal to sine squared of x over 2. So it's just a rewriting. That second one is just a rewriting of the identity that I used in the previous one. And I can further solve this just for the 1 minus cosine x, which will leave me with 1 minus cosine x equals 2 sine squared x over 2. Now I'm going to use these two pieces of information to help me integrate here. I'm going to take that numerator and I'm going to rewrite it as 2 sine x over 2 cosine x over 2 quantity squared. And in the denominator, I'm going to replace the 1 minus cosine x with what I have down here. So I've got 2 sine x over 2 cosine x over 2 whole quantity squared. And in the denominator inside that radical, I've got 2 sine squared x over 2. Now I'm going to square everything in the numerator, and I'm going to deal with the radical in the denominator, and we'll see what we have left. So in the numerator, I have 4 sine squared x over 2 cosine squared x over 2. In the denominator, the square root of 2, I can't do anything about that, but the square root of sine squared is just going to be sine x over 2. So with this, I'm going to be able to cancel that sine x over 2 in the denominator. Will cancel with what's in the numerator, and I can even divide the 4 by the square root of 2. So once I do that, I'm left with 2 times the square root of 2 sine of x over 2 cosine squared x over 2. And believe it or not, even though this kind of looks like a mess, we're actually almost done, and we're just about ready to integrate this. I'm going to use a u substitution here. I'm going to let u equal cosine of x over 2. So du is going to be negative sine x over 2. Remember, we need to find the derivative of this times 1/2 dx. So I have the sine of x over 2. I don't have the negative or the 1/2, but we can make that work. So what I'm going to do is in front, I'm going to take 2 square roots of 2 times a negative 2. And the reason I'm doing that is because I'm going to introduce a negative 1/2 inside. So those will cancel each other out. So now I'm ready to go forward with the u substitution. When I do the u substitution, I'll go ahead and change the upper and lower bounds of the integral. So outside, I've got -4 times the square root of 2. U is equal to cosine of x over 2. So for the bottom one, we're looking at cosine of pi over 6. And cosine of pi over 6 is the square root of 3 over 2. For the top one, I've got cosine of pi over 4, and that's equal to 1 over the square root of 2. Inside, I've got u squared du. So I can go ahead and integrate that. Leaves me with 1/3 u cubed, and we will evaluate that from the square root of 3 over 2 to 1 over the square root of 2. If I bring the 1/3 here in front, I've got -4 times the square root of 2 over 3. Cubing 1 over the square root of 2 leaves me with 1 over 2 times the square root of 2 minus. When I cube the square root of 3 over 2, I get 3 times the square root of 3 over 8. Now there's a couple ways you could go about doing this next part here. I'm just going to walk through it and just kind of write the answer. When I take my -4 square root of 2 over 3 times the first term, okay, the square root of 2's will cancel, and the 2 in the denominator cancels with the 4 in the numerator here, leaving me with just a -2/3. Now let's move to the second term. Well, first off, negative times negative is going to be positive. The 3 in the denominator here will cancel with the 3 here, leaving me right now with the square root of 3 in the numerator. The 4 here cancels with the 8 here, okay, leaving me with a 2 in the denominator, but I still have the square root of 2 here. So the square root of 2 and the 2 down here leaves me with the square root of 2 in the denominator. So I've got -2/3 plus the square root of 3 over the square root of 2. You could rewrite that as one fraction, so -2/3 plus the square root of 3/2.